Hello everyone, we are the group 6 and I am Jerica Sohayon. So for today we will discuss the other sensory systems. So now we will focus on the audition. Audition is the formal phrase for hearing. Sound and the ear. So the ears are organs of hearing and balance. Sound waves are picked up by the ear, converted into electrical impulses and sent to the brain where they are processed. So as we all know, hearing is essential in maintaining good relationships and connections with other people. So it enables us to participate and communicate with others. So ang hearing, so naa siya process. Dili lang siya kay nadungog nato, mao na siya. So naa siya process. First is sa ear, and then padulong sa brain, and then ang brain na ang mag-interpret kung unsa ang iyang nadunggan. So now we will discuss the auditory system, how the sound or waves is being processed sa ear papuntang brain. So physics and psychology of the sound. Sound waves are periodic compressions of air, water, or other media. In physics, sound is a vibration that propagates as an acoustic wave through a transmission medium such as gas, liquid, or solid. In human physiology and psychology, sound is the reception of such waves and their perception by the brain. So, ngayon, we will talk about the amplitude, frequency, pitch, and timbre. So, the amplitude of a sound wave is its intensity. So, if it say amplitude, it talks about the volume or the loudness of the sound. So, it refers to the sound pressure, level, or intensity. The frequency of a sound is the number of compressions per second measured in hertz. So, the number of waves that pass a certain point is given time frame. So, for example, sa frequency is 68 beats per minute. So, parang mayroon siyang time frame. And then, pitch is related aspect of perception. Sounds higher in frequency are higher in pitch. Timbre meaning the tone quality or tone complexity. So, timbre is the quality of the sound. Next is the four sound waves. So the four sound waves are low frequency, higher frequency, low amplitude, higher amplitude. So pag low frequency, the sound is low and soft. Pag higher frequency, ang sound is low and loud. Then pag low amplitude, it is high and soft. Then pag higher amplitude, it is high and loud. So the structure of the ear. So Rube Goldberg draw cartoons of complicated, far-fetched interventions. So the ear is divided into three interconnecting sections: external, middle, and inner ears. So kani diri nga part mao ni siya ang external ear. The middle ear dire and the middle ear and the inner ear. So papunta na ni ay kaning auditory nerve padulong sa brain. So ang brain ang mag-interpret sa wave nga nadunggan. So the pinna, the familiar structure of flesh and cartilage attached to each side of the head, helps to locate the source of the sound. Tympanic membrane vibrates at the same frequency as the sound waves that strikes it. When sound waves strike the tympanic membrane, they vibrate three tiny bones, the hammer, anvil, and stirrup, that convert the sound waves into stronger vibration in the fluid-filled cochlea. Those vibrations displace the hair cells along the basilar membrane in the cochlea. A cross-section through the cochlea, a close-up of the hair cells. So let's go back to the structure of the ear. So ang waves, if mo sulod first mo ni siya ang pinada, external part of the brain. So ang waves is mo travel siya like ang atong nadunggan mo travel siya sa diri sa ear canal, which is also known as external auditory canal, padulong sa mo vibrate ning tympanic membrane or the eardrum. Then kaning eardrum is connected siya sa three tiny bones, the hammer, anvil, and the stirrup. So ang waves mo transmit dayon siya padulong sa cochlea. And then so sulod aning cochlea naa ang hair cells, so called stereocilia. So diri ano ang wave, then ma-process na siya diri, and then pag abot diri sa auditory nerve is send sa auditory nerve sa brain, and mao na to nga i-interpret sa nerve sa brain ang katong nadunggan kung unsa to nga wave. And then mao ni siya ang close-up nga structure sa cochlea. So the kaning cochlea it is a shape like snail and is the size of a garden pea. So next. So dara, mao ni siya ang structure sa hair cells sa sulod sa human cochlea. So oval window, a membrane of the inner ear. The tympanic membrane is larger than the footplate of the stirrup, which connects the oval window as in hydraulic pump. The vibration of the tympanic membrane transform into more forceful vibrations of the smaller stirrup. The net effect converts the sound waves into waves of greater pressure on the small oval window. This transformation is important because vibrations in the ear could not directly produce significant vibrations in the viscous fluid behind the oval window. So, dara. Cochlea is a snail-shaped structure. The cochlea is filled with fluid that moves in a response to the vibrations from the oval window. So, mao ni ang cochlea. So, dara. So, diri nga part, parang stiff ang iyahang sound. Mao ni siya ang cochlea. And then the hair cells, the auditory receptors, lie between the basilar membrane of the cochlea on one side and the tectorial membrane of the other. Vibrations in the fluid of the cochlea displace the hair cells, which respond to displacements small, about the diameter of an atom, thereby opening ion channels in its membrane. So next, pitch perception. So pitch perception is our ability to understand speech or enjoy music depends on our ability to differentiate among sounds of different frequency. So according to the place theory, the basilar membrane resembles the string of a piano, with each area along the membrane tuned to a specific frequency. So place theory, it's about different frequency of sound waves are going to ultimately activate different locations along the basilar membrane. And according to the frequency theory, the basilar membrane vibrates in synchrony with a sound, causing auditory nerve axons to produce action potential at the same frequency. Brain monitors rate of neural impulses traveling up auditory nerve. So good for low pitch, not for high pitch. And according to the Vallee principle of pitch discrimination, the auditory nerve as a whole produces valleys of impulses for sound up to about 4,000 per second, even though no individual axon approaches that frequency. So, the basilar membrane varies from stiff at its base, where the stirrup meets the cochlea, to floppy at the other end of the cochlea, the apex. The hair cells along the basilar membrane have different properties based on their locations, and they act as tuned resonators that vibrate only for sound waves of a particular frequency. So, amusia, the inability to distinguish differences in musical pitch tone deafness. So, ay the basilar membrane mao na siya ang main mechanical element of the inner ear. So, kani. And then ang amusia kanang kuan gud they can't recognize a tune kanang tao na kanang if sa kanta pa siya parang dili siya makasabay sa kanta kay dili niya ma-recognize ang tono sa kanta. So the inability to distinguish differences in musical pitch or tone deafness. And absolute pitch is the ability to hear a note and identify it. So next, the auditory cortex. So as information from the auditory system passes through subcortical areas, axons cross over in the midbrain to enable each hemisphere or forebrain to get more of its input from the opposite ear. The information ultimately reaches the primary auditory cortex, area A1, in the superior temporal cortex. So, di ba, na-process na ang wave sa auditory system and then abot na siya sa auditory nerve. So, ang auditory nerve, isend niya sa brain and then dito na po mag-process and then i-process na po sa brain. So, i-interpret na sa brain kung unsa tong wave or unsa to nga sound ang nakasulod. So, next. So, dara. First, na diri ang wave and then diri pod and then process siya. Imo travel ang wave papunta diri and then diri. So, ang primary auditory cortex kani mo ang mag-interpret kung unsa ba to. So, mo ni siya ang kanang primary auditory cortex. So dara ma-determine niya kung unsa na to ang wave na ilang nadunggan, like for example piano. So the highest notes of the piano, the octave above highest piano notes. So nahibalo niya nga piano to higher ba or something. So ang primary auditory cortex ay ang process. It becomes active when people view short silent videos that suggest sounds such as someone playing piano or a glass vase shattering on the ground. So the visual and auditory systems differ in this respect, whereas damage to area V1 leaves someone blind, damage to area A1 does not produce deafness. So auditory cortex is active during auditory imagery. So if naay damage, so syempre apektuhan jud ang sense of hearing sa isa ka tao. So which is connected sa atong next, the hearing loss. So the two categories of hearing loss are conductive deafness and nerve deafness. Diseases, infections, or tumorous bone growth can prevent the middle ear from transmitting sound waves properly to cochlea. So the two categories of hearing loss is the conductive deafness and nerve deafness. So first, let us talk about conductive deafness or middle ear deafness. is something temporary. If it persists, it can be corrected by surgery or by hearing aids that amplify the stimulus. People with conductive deafness have normal cochlea and auditory nerve. They readily hear their own voice conducted through the bones of the skull directly to the cochlea, bypassing the middle ear. So conductive deafness, so it can be treated with medicine or surgery. Um, Blockage of ear canal could be the reason of this, and then there must be a problem in the three tiny bones. Next is the nerve deafness or inner ear deafness. So, results from damage to the cochlea, the hair cells, or the auditory nerve. It can occur in any degree and may be confined to one part of the cochlea, which impairs hearing of certain frequency and not others. Nerve deafness can be inherited. It can result from disease or it can result from exposure to loud noises. Nerve deafness often produces tinnitus, frequent or constant ringing in the ear. So sa nerve deafness, ang inner part na jud sa ear ang ma-damage. So, mas critical siya kaysa sa conductive deafness. Kay na-damage naman ang possible na na-damage sa cochlea, hair cells, or the auditory nerve. Next is the hearing, attention, and old age. So healthy hearing results in positive health outcomes, increases social engagement, improves communication, and lower the risk of depression. When a person has damaged auditory system, such as with hearing loss, perceptual organization may also be impaired, making it more difficult to direct attention to direct auditory objects in the environment. So many older people have a decrease in inhibitory neurotransmitter in the auditory portions of the brain. So, sound localization. Sound localization refers to ability to identify the direction of a sound. Like, for example, na ay gamit na matagak and then bisag wala ta nakakita or wala ta kabalo asa siya nga area na tagak. So, sound localization, siya is the ability, mahibaw-an niya kung asa to nga area by the process of hearing. So, time of arrival is most useful for localizing sounds with sudden onset. Another cue for localization is the difference in intensity between the ears. For high-frequency sounds with a wavelength shorter than the width of the head creates a sound shadow, making the sound louder for the closer ear. So, parehaan ng kusog ang impact sa or kusog ang sound. So, nadjud sa atong hunahuna nga basin duol lang nara sa duol natagak ang object or parang nang kusog pagka or kusog ang wave, kusog ang sound. Maybe maghunaw na ta nga dako ang object nga natagak or yes. And so the next reporter will discuss the mechanical senses. And that ends my report. Thank you.
So, good morning everyone. I am the second reporter. So, I'll be talking about the mechanical senses. So, what is mechanical senses? The mechanical senses respond to pressure, bending, or other distortions of a receptor. They include touch, pain, and other body sensation as well as vestibular sensations, which detects the position and movement of the head. Vestibular sensation. The vestibular system detects the position and acceleration of the head and adjusts body posture and eye movements accordingly. When you move your head, the vestibular organ adjacent to the cochlea monitors movements and direct compensatory movements of your eyes. As Figure 1 shows, the major sensory organs are utricle, saccule, and the three semicircular canals of this system and are located next to the cochlea and the inner ear. Vestibular organ. Vestibular organ consists of the saccule, the utricle, and three semicircular canals. The saccule and utricle detect gravity and linear movement. The semicircular canals detect rotational movement, are located at the right angles of each other, and are filled with endolymphatic fluid and lined with hair cells. So in addition to maintaining balance, vestibular system collects information critical for controlling movement and reflexes that move various parts of our bodies to compensate for changes in any body position. So therefore, both proprioception or perception of body position and kinesthesia or perception of the body's movement through space interact with information provided by the vestibular organs. So the next sensation is somatosensation. The somatosensory system, the sensation of the body and its movement, is not one sense but many, including discriminative touch, which identify the shape of an object, deep pressure, cold, warmth, pain, itch, tickle, and position and movement of joints. The somatosensory system is also known as the somatic senses, touch or tactile perception. Anatomically speaking, the somatosensory system is a network of neurons that help humans recognize objects, discriminate textures, generate sensory motor feedback, and exchange social cues. In addition, it also comprises those elements of the peripheral nervous system and the central nervous system, subserving the modalities of touch, vibration, temperature, pain, and kinesthesia. Somatosensory receptors. Stimulation of touch receptor opens sodium channels in the axon, thereby starting an action potential. First is Pacinian corpuscle, which detects sudden displacement or high-frequency vibration on the skin. In addition, it is also known as encapsulated ending of the sensory nerve that acts as a receptor for pressure and vibration. Merkel dust. Respond to light touch, such as if someone gently strokes your skin or if you feel an object. Capsaicin. A chemical found in hot peppers such as jalapeno stimulates the receptor for painful heat. So capsaicin can produce burning or stinging sensations on many parts of your body, as you may have experienced if you ever touched the insides of hot peppers and then rub your eyes. So let's answer this question. How do jalapenos produce a hot sensation? Jalapenos and other hot peppers contain capsaicin, which stimulate receptors that are very sensitive to heat. So, somatosensory receptors and probable functions. Free nerve ending or the unmyelinated or thinly myelinated axon. The location is near base of hairs elsewhere in skin. Responds to pain, warmth, and cold. Hair follicle receptors. Hair-covered skin. The responds to movement of hairs. Listener's corpuscle hairless areas. Sudden displacement of skin or low-frequency vibration. In Pacinian corpuscle, the location is both hairy and hairless skin. The response to sudden displacement of skin, high-frequency vibration. Merkel dust location is both hairy and hairless skin, light touch, responds to light touch. Ruffini endings, both hairy and hairless skin, so it responds to stretch of skin and bruise and bulbs, mostly or entirely in hairless areas, perhaps including genitals. Responds to uncertains. In addition to Ruffini endings, it is slowly adapting encapsulate receptors that detect skin when stretching or when joint activity and warmth. So this is the figure. Sensory receptors in the skin that the receptors respond to several types of skin sensation as described in this table. Tickle. The sensation of tickles is interesting but poorly understood. Tickle, also known as paresthesia, refers to a burning or prickling sensation that is usually felt in the hands, arms, or legs, or feet, but can also occur in other parts of the body. The sensation, which happens without warning, is usually painless and described as tingling or numbness, skin crawling, or itching. So that's all with my part, and thank you for listening.
Hi, I am Charlemagne Dipas and I will be discussing somatosensation in the central nervous system. Somasensory cortex is a part of the brain that receives all sensory from all parts of the body. The somatosensory cortex acts as a map of the body location as shown in figure 3.24 in the book that was given. Information from touch receptors in the head enters the central nervous system through the cranial nerves, and information from receptors below the head enters the spinal cord and passes towards the brain through the 31 spinal nerves, including 8 cervical nerves, 12 thoracic nerves, 5 lumbar nerves, 5 sacral nerves, and 1 esophageal nerve. Each spinal nerve innervates or is connected to a limited area of the body called a dermatome, which you can see in this image the bluish color and the flesh color. The sensory information traveling through the spinal cord follows well-defined pathways towards the brain. In this image, we can see the cervical nerves, the thoracic nerves, the lumbar nerves, the sacral nerves, and the esophageal nerves. The human central nervous system has spinal nerves from each segment of the spinal cord that exits through the correspondingly numbered opening between vertebrae, which is shown in the image. Damage to the somatosensory cortex impairs body perception because basically somasensory cortex receives all sensory from all parts of the body, which means its perception. The primary somatosensory cortex is essential for touch experiences. And if the somasensory cortex is damaged, then we will not be able to feel pain and we will not be able to know that our tissue are damaged, because pain is the unpleasant experience caused by the potential damage in the tissue, and experience evoked by a harmful stimulus that directs your attention towards a danger. The, the prefrontal cortex regulates our thoughts, actions, and emotions, which is important for attention. Typically responds only briefly to any new light, sound, or touch. With pain, it continues responding as long as the pain lasts. Stimuli and spinal cord path. Pain sensation begins with the least specialized of all receptors, a bare nerve ending or a free nerve ending. Bare nerve ending are the most common nerve ending in skin. They are sensitive to painful stimuli, to hot and cold, and to light touch. They are slow to adjust to a stimulus and so are less sensitive to abrupt changes in stimulation. The axons carrying pain information have little or no myelin sheath and therefore conduct impulses relatively slow in a range of 2 to 20 meters per second, which means that brain receives pain information slower than other sensations but processes it faster, making the motor response faster to pain than touch. The thicker and faster accents convey sharp pain, and the thinner ones convey duller pain, such as post-surgical pain. Emotional pain. If you watch someone, especially someone you care about, experiencing pain, you experience sympathetic pain that shows up as activity in your cingulate cortex and other cortical areas. A hypnotic suggestions to feel no pain decreases the response in the cingulate cortex without much effect on the somatosensory cortex, because hypnotic suggestion modulates attentional control, which modifies emotion and the nervous system, and not the somatosensory cortex. Someone responding to hypnotic sensation still feels the painful sensation but reacts with emotional indifference, because basically the hypnotic sensation only decreases the response in the cingulate cortex, which is the part of your brain that reacts to sensation emotional associations, and not the sensory part of sensations. Well, in this figure, we can actually see the spinal pathways for touch and pain, not emotional pain. As you can see, we have a blue line that shows the pathway for discriminative touch, such as recognizing of shape or size or texture. And the red line shows us the pathway for pain, temperature, and tickle. In the discriminative touch, we can see that it enters the spinal cord to the thalamus. However, in the medulla, the pathway begins to shift in the right side. As you can see in the midbrain, it has shifted its places, or decussated or moved to the other side, and then straight to the thalamus, where it is being filtered out to which part it felt the pain. And the pain information pathway is being sent to spinal cord. However, unlike the discriminative touch, its decussation is already being processed in the spinal cord segments, where you can see the pain information pathway is in the right side of this image, and then straight to the thalamus, unlike the discriminative touch information pathway, which has the moved from to the other side during the medulla. That is why the pain information pathway is also called the spinothalamic pathway, because its pathway is straight from the spinal cord to the thalamus. So what happens with more intense hurt feelings? Well, actually, this is the continuation of emotional pain. So in this case, the hurt feelings showed up as activity in both the emotional areas and the sensory areas, not just the emotional areas. This includes the sensory areas if the hurt feelings is intense. And so when we have an intense hurt feelings, we can use pain relieving drugs such as acetaminophen or Tylenol. Here are the ways of relieving pain. We can use opioids and endorphins. After pain alerts you to a danger, or continuing pain messages are unnecessary. The brain puts the brakes on the prolonged pain by opioid mechanism systems that responds to opiate drugs and similar chemicals, such as endorphin. Candice Pert and Solomon Snyder discovered that opiates bind to receptors found mostly in the spinal cord and the periaqueductal gray of the midbrain. The transmitters that attach to the same receptors as morphines are known as endorphins, a contraction of endogenous morphine. Where, as you can see here, the endorphin attaches just like keys to the receptor of opioid, and the endorphin acts as the key for the opiate receptor to stop or pause the sending of pain information. Well, in this we can also see that the release of endorphins, which inhibits or restrains an inhibitory cell and therefore excites the other transmitters, which includes the dopamine, because the inhibitory cells that limits the production of dopamine is being restrained. Thus, dopamine production is released when you use opioid, making you feel more happy and less painful. Other ways of relieving pain: the placebo effect. The placebo, a Latin word which means "I will please," is a treatment that appears real but is designed to have no therapeutic effect. That is why it is more effective to positive people, because positive people tend to think positively, unlike the negative people, which tend to think negatively, which make them feel the pain more. Example of this is when you are being injected and your parents tell you that the injection will only hurt you a bit, just like when ants bite you. So in your head you think that the injection does not hurt at all because ant bites has little pain or none at all. This is what placebo effect means. Cannabinoids. Cannabinoids are chemicals that are related to marijuana, which also blocks the part or kind of skin. Well, unlike opiates, cannabinoids act mainly in the periphery of the body. So if you delete its receptor in that area, even if it is still intact in the central nervous system, you will still feel pain. Capsaicin. Capsaicin relieves pain by making your skin feel warm, which blocks pain signals going to brain. Sensitization of pain. Damaged or inflamed tissue, such as sunburned skin, releases histamine, nerve growth factor, and other chemicals that help repair the damage but also magnify the responses of nearby heat and pain receptors. Stimulation of the facilitated pain receptors releases chemicals that cause swelling and inflammation. Non-steroidal anti-inflammatory drugs such as ibuprofen relieve pain by reducing the release of chemicals from damaged tissues. Itch. We have two kinds of itch that feel about the same although their causes are different. First, when you have mild tissue damage, such as when your skin is healing after a cut, your skin releases histamines that dilate blood vessels and produce an itching sensation. Second, contact with certain plants, especially cowhage, a tropical plant with barbed hairs that which also produces itch. Antihistamine block the itch that histamines cause, but not the itch that cowhage cause, because basically it means antihistamine. Conversely, rubbing the skin with capsaicin relieves the itch that cowhage causes, but it has little effect on the itch that histamine causes. Itch axons activate certain neurons in the spinal cord that produce a chemical called gastrin-releasing peptide. And by blocking the peptide, it has been shown to decrease scratching in mice without affecting their responses to pain. And this has proved how pain, touch, and itch are different. And that is all for the mechanical sensory. Thank you, everyone.
Good day, everyone. My name is Laika Gomez, and I'm going to talk about chemical senses. Chemical senses is two, which is taste and olfactory. Olfactory, which means the smell. So before we talk about chemical senses, we have first talk about chemical coding. Label line principle. Each receptor would respond to a limited range of stimuli, and the meaning would depend entirely on which neutrons are active. So, label line principle is just limited range, while across the fiber pattern principle, each receptor responds to a wider range of stimulus. A given response by a given axon means little except in comparison to the other axons are doing. So the across fiber tau is range, wide range, very wide siya. So here are the chemical senses, taste and olfaction. So first the taste, it is the result from the stimulus of taste buds. Ito yung na ito yung stimulus, like ito yung kinakain natin. Like once na kumakain tayo, nag-react yung taste buds, which is we have the taste receptors, the taste buds. Ito yung nalalasahan natin. Sila yung dahilan kung ba't may nalalasahan tayo. So ito, yan, the tongue, and here, yan yung taste buds natin. Yan yung maliliit lang pero malaki yung impact nila. Like ito yung dahilan kung ba't may nalalasahan tayo. So the kinds of taste receptors, we have 5: bitter, sour, salty, sweet, and umami. Yung umami, is surely alam naman natin pero hindi siya minimension lagi. But umami is at the center part. Yan, center part. The bitter is upper. Yan. The acid, which is the sour. Salty. Then sweet. Yan. Then umami yung sa gitna. Again, the sugar, which is the sweet. The next would be the acid, yung sa upper, katabi ng bitter. Then, katabi ng sugar, which is the salty. Yan. And, yan. So, mechanism of taste receptors. Saltiness receptor detects the presence of sodium simply permits sodium ions on the tongue to cross its membrane. So, dito, yung saltiness receptor is like ino-open ng sodium ions ito para pumunta siya sa membrane natin. The SAR receptors detect the presence of acids. So, alam naman natin na SAR is equivalent to acids. Acid is equivalent to SAR. So, sweetness, bitterness, and umami receptors resembles the metaprobic synapses. And lastly, bitter taste would be used to be a puzzle because bitter substances include a long list of dissimilar chemicals. So, yung bitter is very confusing daw siya noon kasi iba-iba yung chemicals na nalasahan natin. So, very siya, like mapait talaga. And they can identify that. So, yan. Taste nerves project the nucleus of the tractilius solitarius or NTS, a structure in the medulla. Yan. Yan yung yung tongue natin sa baba. Then papunta yan kang NTS, then ipapas niya sa brain. Ipapas niya yung message, ito yung nalalasahan natin. So the adaptation reflects the fatigue of receptors sensitive to sour taste, and cross-adaptation reduces response to one taste after exposure to another. Here we have the sweet food and sweet drink. Example nito. Once na mataste mo kasi yung isang sweet and inumin mo ng isang sweet, hindi mo na malalasahan yung taste ng sweetness kasi ito, the result of the brain rat, yan, malaki yung sucrose, which is the sweet, yung saltiness, konti lang, yung sour, yan. So, variations in taste sensitivity, there are three, super taster, tasters, and non-tasters. So, yung non-tasters, ito yung parang konti lang yung nalalasahan, not really sensitive when it comes to taste. Yung tasters, sila yung normal. Siguro may iba na may advanced, pero mostly normal. Then the super tasters, sila yung napaka-sensitive ng taste. Grabe yung oozing na panlasa nila. So, olfaction, the sense of smell, and the response to chemicals that contact the membranes inside the nose. And olfaction receptors, the neurons responsible for small are the olfactory cells that line the olfactory epithelium in the rear of the nasal passages. The implication for coding. Unlike other sensors that have only 3 cones or 3 receptors, olfactory receptors have many. So, yung ibang sensors is ma-identify mo lang either 3 or 5 gaya ng smell, gaya ng taste. There are only 5, the umami, sweetness, bitterness, saltiness, and the sourness. Yan, sila 5. But in olfactory receptors, marami. Kaya once na may naamoy tayo, hindi agad natin ma-identify na ganito sweet, ganito bitter, ganon. Hindi natin agad ma-identify. Magmi-mix yan. So, messages to the brain. When the olfactory receptors is stimulated, it senses certain impulsa towards the olfactory bulb. The pleasant or odor tends to group together and unpleasant odor together. The olfactory bulbs send senses to the olfactory area of the cerebral cortex, and olfactory receptors are vulnerable to damage because they are um, exposed to the air. So, yung olfactory receptors natin is very damaged siya. Ay, hindi pala. Vulnerable sa damage because of the thing na yun nga, naamoy natin yung kahit ano-ano, hindi natin alam if toxic ba yung naamoy natin o hindi. So, parang nagmi-mix yung mga chemicals and ayun, naamoy natin. So, uh, nag, nagkaka-damage siya, which is, yun yung time na hindi na, wala tayong maamoy. And, lastly is the synesthesia, is the experience some people have in which stimulation of one sense evokes a perception of that sense and another one also. So, ito yung synesthesia, like, parang yung sense of smell, for example, naamoy natin, may naamoy tayo, something citrusy, ganun. Yung sa synesthesia, yung naamoy nila, nakikita nila yung kulay, for example, like that. Nakikita nila yung kulay, ang citrusy, parang yellow daw siya, ganun, ganyan. So, yan yung synesthesia. And that's all for the topic for the report. Thank you.